Hi, hello, how are you? Good evening, everybody. Welcome to India's number one online platform, Gradeup, and welcome to my class of operating system. So, today we will discuss operating system. So, please join me, everybody, so we can start the session. Now, as usual, I will ask some question, but before the question, let me tell you about the topic of today: non-contiguous memory management techniques. Contiguous memory management technique we have already seen. Now today we will see non-contiguous. So quickly, please like the session, subscribe and click on the bell icon and share the channel. So at least you can share it, and you can like it. This you will not be losing anything. You have to click on the share button so that I can see how many of you are sharing this channel, right? This is all about me. My name is Navneet Gupta. I have 8 years of teaching experience. I got 92nd rank in GATE 2008 and so many more things. You can just read it out here. Now here is the first question. So in internal fragmentation, memory is internal to a partition and dash internal fragmentation we are talking about. Today I have to code, so please adjust with me. Hmm. So in the internal fragmentation, memory will be used or not used, they are asking, because memory is internal to a partition. Okay, we have this memory, and here suppose I have this partition of 8K, and I am loading one process P1 of 6K. So this is block, and I will be loading this. Now this memory will not be used, it, because in one block only one process will go in the internal fragmentation. So the answer of this question will be option number B. So basically memory is not used. Okay, memory will not be used in the internal fragmentation. Tabhi to we will say it is internal fragmentation. This is the question number 2. Tell me the answer. Right, Shobhagya? Okay. Now tell me here, the second question is, if relocation is static and is done at assembly or load time, then the compaction, static, relocation is static, then compaction can be done, cannot be done. And it is done at assembly or load time. So today's question, I have taken some good questions, right? Sorry. So here I will tell you the answer now. So if it is static, it cannot be done. Static means you are doing loading at the compile time. So you cannot do compaction. Why? What is the meaning of compaction? I told you. Suppose we have some processes and some area allocated, like this process, we have this process, we have this process. Now, what I can do, I can make this allocated area to up one and here up one. So at the one end, I will be having all the processes, that is occupied area, like this one, and I will be having free space. So this is known as compaction. So but compaction, देखो, compaction will be when we will do compaction. So here the address, that is the base address, and the limit to same ही रहेगी, but the base address of this process number 2, process number 3 will be modified at the runtime na. So because only we can move the processes upward or downward, right? So but if it is static, not dynamic, static means it is done at the compile time, so compaction cannot be done, we cannot move the processes. Only we can move when it is dynamic, means loading will be done at the execution time, then only compaction can be done. That is, and compaction is also not optimal. Why? Because compaction is slow. Now tell me the question number third. I hope question number 2 is clear. Which question I should explain, Saubhagya? Okay, so please everybody click on the like button so I can see your name. I can see your presence. So in this question, what they are saying is dash is generally faster than dash and dash. So I hope now you can tell the answer. Very good, Dayanand Singh, correct answer. But Saubhagya, third, please check the answer. Yes, Gayatri, what is the answer? Kulleshwari, okay. Beta, best fit will be faster. Dash is generally faster. So for best fit and worst fit, what we have to check? We have to check all free holes, right? And then we have to see the wastage, that is a fragmentation कि minimum fragmentation और maximum fragmentation, right? किसमें कम हो रहा है और किसमें ज्यादा हो रहा है. So this is best fit and worst fit. So ये क्या होते हैं? स्लो होते हैं बेटा, right? बट फर्स्ट फिट में क्या है, जो भी पहले मिल जाएगा उसी में डाल देंगे, ठीक है? सो देन, सो डेफिनेटली डैश इज फास्टर देन बेस्ट फिट. ये तो बहुत इजी है. द आंसर ऑफ दिस क्वेश्चन इज ए, करेक्ट. बिकॉज इन द बेस्ट फिट एंड वर्स्ट फिट हम ये चेक करेंगे ना कि कौन सा वाला किसमें ज्यादा वेस्टेज हो रही है और किसमें कम वेस्टेज हो रही है, इसीलिए हमारा आंसर होगा ए. हाँ, ए इज द आंसर, राइट. Okay, now here, before to the next question number 4, I will tell you very important information regarding Vision 2022. So this is a course for GATE and PSUs. Okay, if you are in second year or you are in third year college, so this course will be beneficial for you. And we have launched batch number 3. Okay, so in this course, basically these are the details, you can just read it out. In this we will provide you 550 hours of live class, 5000 practice questions, 100 plus mock test, 100 plus chapter wise study notes. For more information you can contact on this number, right? And actually rank up and gear up are going on for gate 2021, and they are approximately going to be over very soon. Now, here is the question number 4. Tell me the answer of this question number 4. So, in this question number 4, a solution to the problem of external fragmentation is. So, we want to remove external fragmentation. I think this question is very easy. Suppose we have here allocated, then we have free, then we have allocated, then we have free, then we have allocated, like this, huh? So suppose this is 2k, this is 4k. Now I have one process pk which requires 6k. Now 6k cannot come completely here and also not here. but now if we combine 2k and 4k together, so 6k can be combined, है ना. हम 4 और 6 जोड़ 4 और 2 ऐड कर लेंगे तो 6k हो जाएगा. So then for removing external fragmentation, the thing is compaction. Okay, so larger memory space, no. Smaller, no. None. So the answer of this question will be compaction. So basically compaction is the solution of external fragmentation, right? I hope question number 4 is also clear, so that we can go ahead with the next question number 5. Here is the question number 5. Can you tell me the answer of this question? You please answer me very quickly, है ना, जल्दी जल्दी आंसर करो. Sorry. External fragmentation exists when option A, enough total memory exists to satisfy a request but it is not contiguous. Option B, the total memory is insufficient to satisfy a request. A request cannot be satisfied even when the total memory is free. Okay, total memory is free. So here external fragmentation. What will be the problem for external fragmentation? When we have enough memory but it is not contiguous. In the previous I just told you about this one now, the same thing. So the answer of this question will be option number A, 5 ka A. Now here is the next question number 6. So please answers me quickly, है ना, don't take so much time. So here the question is the disadvantage of moving all the process to one end of memory and all holes to the other direction, producing one large hole of available memory. So what is the disadvantage? Advantage is to remove the external fragmentation. What will be the disadvantage of this? In the option number A, the cost incurred. Option number B, the memory used. CPU used all of the mentioned. So what should be the answer? Option number, the correct answer of this question number 6 would be option number A. Cost incurred means basically time. CPU used, no. So because CPU used, CPU तो नहीं आया इसमें, so all of the mentioned will not be there. Okay. And disadvantage is memory used. नहीं, memory तो वैसे भी use हो ही रही थी पहले भी. Cost incurred means basically it will take a lot of time. That is the reason appropriate answer of this question will be option number A. Correct, beta? I hope now it is clear. Now before moving to 7th question, I will tell you about Gradeup. Achha. Okay, I will tell you later, but after question number 7. Tell me the answer of this question number 7. So please click on the like button, everybody. Hi Aman, how are you? Aman, stand up comedy Dube. Okay, hello. Incurred why not C? बेटा C CPU का कोई ना यूज होगा, सौभाग्य। बेसिकली यूज तो हमारा जो है सीपीयू में क्या करेगा कॉम्पैक्शन में, ठीक है, बहुत कम यूज होता है सीपीयू का। श्वेता आई टोल्ड यू एक्सटर्नल फ्रेगमेंटेशन, एक बार और बता देते हैं। सपोज हमारे वी हैव अ मेमोरी, okay, and in the memory we have some allocated area, then we have some free space, then allocated, then we have some free space like this one, we have allocated area. Now suppose this is 2k, this is 1k, 2k, 4k. Okay, now I have a process pi and it is 8k. So see, 4 plus 2 plus 1, 7k. No, pi cannot come completely here and pi cannot come here. But now यदि मैं इसको और इस वाले को कंबाइन कर लूं, so I can have definitely more than 8k. So I can satisfy this request pi, but I am not able to satisfy because this free available area is not contiguous. If it is contiguous, then we would have filled it, this process pi, in the free area. So this memory is being wastage. Okay, so we know, we call it as external fragmentation because ये ब्लॉक के अंदर वेस्टेज नहीं है। ब्लॉक के अंदर वेस्टेज होता तो इंटरनल फ्रेगमेंटेशन, ये मैंने पहली क्लास में बताया था। Another solution to the problem of external fragmentation problem is to solution they are asking. Permit the logical address space of a process to be non-contiguous. Permit smaller processes to be allocated memory at last. Permit larger process, नहीं smaller और larger से तो कुछ फर्क ही नहीं पड़ेगा. So the answer of this question will be option number A, non-contiguous. So logical address space of a process is non-contiguous, means pi, I will break pi and some portion I will store here and some portion of pi I will store here, right? So I can remove the external fragmentation 100%, right? So this is the question number 7. I hope now it is clear. The answer of this question will be option number A. Now before moving to question number 8, I will tell you about Gradeup achievers. So in this year 2020, one student got the rank 4th in computer science and 20 ranker. So you can't believe, more than 60 student have got the rank under 100 AIR. It is really good, okay? And these are the students who taken the admission in the Gradeup, right? And this is about 18 and 19, correct? Now here is the question number 8. So here in this question number 8, when the memory allocated to a process is slightly larger than the process, then option A, internal fragmentation occurs, external fragmentation occurs, both will occur, neither internal nor external. So what would be the answer of this question number 8? So the answer of this question number 8 would be option number A, right? Internal fragmentation, I told you now, when we have memory which is larger than, slightly larger than the process. Suppose we have one memory 16k and one process pi is of 12k. So it will take 12k memory and now it is free 4k. So this is known as internal fragmentation. Why? Because there is no other process can come in this area. मतलब इस वाले एरिया में कोई दूसरा प्रोसेस नहीं आएगा, ठीक है? So we call this internal fragmentation. Now the next question number 9. What would be the answer of this question number 9? Everybody should answer. Sometimes the overhead of keeping track of a whole might be dash. So what they are talking about, so we have to keep track of whole means free space, so it will be overhead. So what is overhead? Why? What will be the problem? So it may be larger than the memory is a larger than the whole itself, very small, all of the mentioned. Think about this question. This is really good question. So the answer of this question will be option number B. So overhead of keeping track of a whole may be larger than the whole itself. Okay. So this may be the reason. Now what will be the answer of this question number 10? So please click everybody on the like button. External fragmentation will not occur when first fit used, best fit used, worst fit used, no matter which algorithm is used, it will always occur. So the answer of this question number 10 will be no matter which algorithm is used, it will always occur. ठीक है, याद रखना, कोई भी algorithm यूज कर लो आप, लेकिन एक्सटर्नल फ्रेगमेंटेशन तो होगा ही होगा. इसी को रिमूव करने के लिए हम क्या पढ़ते हैं? नॉन कॉन्टिगियस मेमोरी मैनेजमेंट. ठीक है, नॉन कॉन्टिगियस मेमोरी मैनेजमेंट. और नॉन कॉन्टिगियस मेमोरी मैनेजमेंट में भी कौन सा पढ़ते हैं हम? बेसिकली पेजिंग. ठीक है. So now we will move to the topic of today, and the topic of today will be this one. So first is need for paging. What is the need of paging? And I just told you what is the need. I think basically the main disadvantage of dynamic partitioning is the external fragmentation, you know. ठीक है. So हालांकि this can be removed, that is external fragmentation we can remove through you can say by compaction. By compaction we can remove it, but compaction is very costly. Costly means it is very inefficient. Okay, that is the reason we can say we need a paging. So here what is the need सो द मेन, बल्कि इसमें लिखना चाहिए डिसएडवांटेज ऑफ डायनेमिक पेजिंग, यहाँ पर द मेन डिसएडवांटेज ऑफ okay, the main disadvantage of dynamic partition is external fragmentation. External fragmentation. Okay, although we can, I will write this line also, ALTH. Although we can remove it through compaction, but it is very inefficient, very costly, that is inefficient. सारे प्रोसेस को मूव करना है ना, ये बहुत इनएफिशिएंट है, इसीलिए वी नीड अ पेजिंग. What we need, why we need non-contiguous paging, I will tell you how to do this. Right, okay. Now if you see example I have taken, suppose we have process P1 and the P1 size is 2 MB and main memory is divided into 3 partitions, and 2 partitions are holes of size 1 MB each. Hole, you know, hole means basically free space. So here P1 need 2 MB. Okay, this is the requirement, and we have main memory. We have 1, 2, 3, right? And out of 3, 2 partitions are 1 MB, 1 MB. So let's take 1 MB, 1 MB, 1 M, 1 M, and about third they have not said anything. So P1 needs basically 2 MB. So it will be loaded into the main memory, but actually we have only 1 MB. But because 3 partition, so let's say this is occupied and 1 MB is this. Why I'm taking this one? Otherwise पता है क्या होता? Otherwise continuation में होते तो ये वो हो जाते merge वेरिएबल में, तो इसलिए मैंने ये बीच में ले लिया. अब ये 2 MB का है, अब ये 2 MB इसमें तो नहीं जा सकता, कंप्लीटली ना इसमें जा सकता है ना. तो ये हमारा क्या हो रहा है, ये हमारा एक तरह से हो रहा है एक्सटर्नल फ्रेगमेंटेशन. 2 MB हम पे अवेलेबल है, लेकिन क्योंकि ये कॉन्टिग्यूअस नहीं है, इसीलिए दिस इज अ you can say serious problem of fragmentation. Okay, so here this is external fragmentation, right? And this, using the diagram I have shown you, operating system, and 1 MB is free and 1 MB is free, and some processes here I have occupied. Now 2 MB I have 2 MB process. Now 2 MB, if I can divide 2 MB, 1 MB, 1 MB, so 1 MB can go here, 1 MB can go here. So here the process will need to be divided into 2 parts. Only then we can store this, or we can remove this 2 MB external fragmentation. समझ में आ रहा है आपको? I hope you are understanding. Basic है ये तो अभी. Yes, if you have any doubt, please let me know. So now, before taking one more example, I will tell you about the fee structure of the Gradeup. So if you purchase any course in the Gradeup Super, so it is just for 9,000 rupees for 3 months. For 12 months, it is 22,200. For 18 months, it is 30,600. And for 24 months, it is 36,000. So as per my personal suggestion, you can just take the 12-month subscription, Okay, and you can access unlimited courses, okay, in computer science. For more information you can contact on this number. Also you can send email on this email ID. Now here I will take the example of paging, right? So here the main idea behind the paging is to divide each process in the form of pages and frames. So what is page and frame? Suppose we have a process pi. Let me take process pi. Now this is very long. Let's say this is 16 kb MB. ठीक है, the size of this process is 16 MB and I don't have space, continuation में space नहीं है 16 MB, वैसे बहुत है. What I will do, I will just divide my process into parts, like one part, two part, three part, four part. So this is one part, two part, three part, four part and five part. So these parts, or you can say these units, are known as pages. So मतलब क्या हुआ कि process is divided into pages and what is inside the page? Page के अंदर क्या होगा? So page contain instruction. क्यों? क्योंकि भाई फाइनली प्रोसेस के अंदर क्या है? इंस्ट्रक्शन, लाइक प्रिंट एफ, स्कैन एफ, है ना? आई हैव डिवाइडेड, फॉर एग्जांपल आई हैव रिटन मेन, I have made two variable a b and something I'm scanning, scanf using, printf doing something. So my process is divided, for example this portion, one page, second page, है ना? So page के अंदर क्या होंगे? Page contain instructions, right? I hope now it is clear what is in the page. So this process is divided into pages and main memory will also be divided now. ठीक है, अब when we will use the paging, so main memory means RAM. So basically suppose if you have a RAM, so RAM will be divided into units and these are known as frames. So ये हो गया frame 0, frame 1, frame 2 and frame 3. Okay, and please remember the size of this frame and this frame, all frames are equal. If it is 2 MB, ये भी 2 MB का होगा, 2 MB का 2 MB 2 MB. And please remember जो हमारा एक पेज होगा उसका साइज भी सेम होगा, ठीक है? यानी कि ये भी 2 MB का, ये भी 2 MB का, ये भी 2 MB का, ये भी 2 MB का. तो हमने क्या करा, हमने अपने बहुत बड़े वाले प्रोसेस को डिवाइड कर लिया और बहुत बड़ी वाली रैम को भी डिवाइड कर लिया. लेकिन जो हमने डिवाइड किया है प्रोसेस को और जो हमने डिवाइड किया है रैम को, उनका साइज सेम है. इसको बोलते हैं हम फिक्स्ड पेजिंग. फिक्स्ड पेजिंग यानी कि हर पेज का साइज जो होगा फिक्स्ड होगा. वेरिएबल पेजिंग पर अभी रिसर्च चल रही है, ठीक है, कि किसी का 2 MB ले लिया, किसी का 4 MB, किसी का 6 MB, है ना? बट अभी क्या है, फिक्स्ड होगा. मतलब एवरी पेज विल बी डिवाइडेड इनटू फिक्स्ड साइज and every frame is also divided into fixed size and the size of frame and the size of page will be equal, right? Now see what do you mean by paging one more. So I have divided my process और जब भी whenever I will need one page then the page will be loaded into main memory, जहां भी उसे जगह मिलेगी. otherwise वो क्या होगा, otherwise it will be remaining into my same hard disk. ठीक है, hard disk means secondary storage. So I will write this line also, what I told you. Okay, so I have written one more line. So let me remove it, or I have written here. ठीक है, so pages of the process are brought into the main memory only when they are required, otherwise they will reside in the secondary storage यानी कि hard disk. क्लियर नाउ? बोलो, यहां तक समझ में आया कि ये हमारा मतलब क्या है? व्हाट डू यू मीन बाय दिस वन, कि पेजिंग की नीड क्यों पड़ रही है? एंड नाउ वी कैन सी this the same thing in the form of diagram. देखो यहाँ मैंने फेयर डायग्राम बनाया, यहाँ पर मैंने रफ डायग्राम समझाने के लिए। नाउ वी हैव ऑपरेटिंग सिस्टम, सो दिस इज मेन मेमोरी. Main memory is divided into frame 1, 2, 3, 4, 5, 6, and we have process is also divided into pages, and now this page will be loaded into main memory wherever it will have a space in the RAM. Suppose page 5 can go here. I will take the example, don't worry. Right, so we will call mapping means कि अब ये पेज 5 मेरा कौन से फ्रेम में पड़ा है ये भी तो देखना है, मतलब लॉजिकल एड्रेस से फिजिकल एड्रेस में मैप करना. ठीक है, लॉजिकल एड्रेस टू फिजिकल एड्रेस मैपिंग. तो ये हमारा क्या हुआ, मैपिंग हुआ. आई होप यहाँ तक कोई प्रॉब्लम नहीं होगी. सो वी कैन टेक वन एग्जाम्पल. ओके, सो एग्जाम्पल के लिए मेन मेमोरी साइज यानी कि रैम साइज इज 16 MB. Excuse me, I have code actually, so I just wanted to cancel the class, but मैंने सोचा नहीं स्टूडेंट का लॉस होगा तो क्लास को ले लेते हैं. तो 16 MB. अब मैंने इसमें एज्यूम किया फ्रेम साइज इज 1 KB. 1 KB ले लेते हैं, KB ले लेते हैं, MB की जगह KB. So frame size is 1 KB and main memory is 16 KB. So definitely main memory will be divided. So how many frames? Can you tell me based on this? Total frames will be definitely total frames will be 16 and each of 1 KB size, right? Now let me take, suppose we have 4 process P1, P2, P3 and P4, right? और ये भी, इसको भी 4 KB चाहिए, ये भी 4 KB, 4 KB, 4 KB, 4 KB. आई एम टेकिंग ऑल. अब देखो क्योंकि हमारा फ्रेम का साइज 1 KB है, सो देयरफॉर डेफिनेटली पेज साइज जो है, PS लिख रहा हूं मैं, पेज साइज विल आल्सो बी 1 KB, राइट? सो यानी कि पेज P1 के टोटल पेजेस कितने होंगे? टोटल पेजेस ऑफ P1 4 है ना, इसके भी 4 होंगे, इसके भी 4 पेज होंगे, इसके भी 4 और इसके भी 4. ठीक है, 4 4 क्योंकि 1 KB का है, एक भाई 1 फ्रेम में जाना है ना, 1 फ्रेम के अंदर जाना है, इसलिए हमने क्या करा, ये एज्यूम किया. करेक्ट. नाउ हियर इफ यू गो अहेड, सो आई हैव टेकन दिस एग्जांपल. नाउ इसको यदि हम डायग्राम की फॉर्म में देखें, फेयर डायग्राम की, तो यहाँ पर ऐसे भी हम शो कर सकते हैं कि एक फ्रेम हमारा 1 KB का है. सो फ्रेम साइज पेज साइज इक्वल होते हैं. वेरी इंपॉर्टेंट पॉइंट, प्लीज रिमेंबर. सो ये हमारे क्या है, हमने बोला कि 16 KB की है. अब मैंने बोला कि प्रोसेस P1 के 4 पेज मेरे यहाँ लोड हो गए. मे बी हो सकता है कॉन्टिन्यूएशन में ना हो सकता है कॉन्टिन्यूएशन में हो. यदि जब हमारी रैम फ्री है तो कॉन्टिन्यूएशन में हो जाएंगे. फिर प्रोसेस 2 के हमारे यहाँ लोड हो गए, प्रोसेस 3 के यहाँ हो गए, प्रोसेस 4 के यहाँ हो गए. ठीक है, ऐसे लोड हो गए. व्हेन आवर मेन मेमोरी इज कंप्लीटली फ्री. ऐसा भी नहीं है P1 यहाँ हो सकता है हमारा, देन P1 में भी पॉसिबल यहाँ हो जाए, P2 यहाँ हो जाए, है ना, ऐसा भी पॉसिबल है. फिलहाल मैंने क्या किया, कॉन्टिन्यूएशन में दिखाया आपको कि कैसे हमारा होगा. तो ये हमारा क्या है, पेजिंग, एक तरह से पेजिंग ही चल रही है ये. ओके, नाउ इसी चीज को अब हम देखते हैं कि सपोज हम पे एक P5 आया जिसका साइज क्या है 8 KB, यानी कि 8 पेजेस बनेंगे भाई, 1 KB का एक है. सो इट इज वेटिंग इनसाइड द रेडी क्यू. ठीक है, यू नो दिस. सो P5 इज वेटिंग फॉर इन द प्रोसेस. अब देखो, अब क्या है, जब हमारा कोई भी प्रोसेस फ्री होगा तभी होगा. तो लेट्स सपोज कि हमारा P2 और P4 फ्री हो गए, मतलब P4 एंड P2 जो है वो फ्री हो गए. फ्री होने का मतलब है उनका काम पूरा हो गया. तो जब हो गई तो अब हमारा क्या है, कॉन्टिन्यूअस तो नहीं है ना P2 P4. तो अब मैं क्या करूंगा, P5 के थोड़े से पेज यहाँ लोड कर दिए, 4 और 4 यहाँ कर दिए, तो देखो ये क्या है, ये चीज और ये चीज हो गई ना नॉन कॉन्टिगियस। नॉन कॉन्टिगियस, बिकॉज ऑफ नॉन कॉन्टिगियस, okay, I am allocating the pages of the P5. I hope you are understanding, right? So this is the example of P5 pages. So we will do a lot of thing in the paging. Okay, so if you have any doubt, please ask me. And tomorrow is 25, so I think on Friday, Saturday, Sunday I will not be having a class, क्योंकि we will not be I will not be available. So tomorrow and the day after tomorrow, that is Friday, Saturday, Sunday, you also enjoy. So most probably on Monday I will recall all the things paging. ठीक है? Now we will wind up the session, and these are the faculty list who will teach you in the computer science. This is all about green card and structured life courses. And definitely I will say bye bye to you. Still, if you have any doubt, please ask me, otherwise I will wind up the session in just 1 minute. Okay, everybody? So bye bye, take care, and we will meet on a Monday. ठीक है, मंडे में we will see some more important points on non-contiguous, that is on paging, right? Okay, bye bye, take care, and have a great day ahead.